Yo, what's up guys? My name is Jade and welcome to the first episode of ENT Club's chemistry-themed miniseries, Jade's quick review on chem topics. I know, what a creative name, right? Okay, anyways, this series is for those of you who, like me, are doing some summer review for the dreaded AP Chemistry, or those of you who are looking to take chemistry, honors or non-honors, next year and want a little head start. If you're new to this channel, please hit the subscribe, but you know what? I'll save the self-promo for later and let you guys get into all the information first to determine whether or not you actually find our channel useful. So today we'll be going over a super important concept in chemistry and a must review for all of you who plan on taking AP Chemistry in the coming year. And what might that be? Well, why don't I give you a hint using the actual best AP Chem song to date.
Chemistry. Over summer, better study stoichiometry.
Yep, that's right. Today we'll be studying stoichiometry. So before we get into actually solving some problems, we should probably go over what in the world stoichiometry even is. Alright, so stoichiometry is defined in the dictionary as the relationship between the relative quantities of substances taking part in a reaction or forming a compound, typically a ratio of whole integers. But what does that even mean? So to put it in simpler words, stoichiometry is a process used in chemistry to figure out how much of each substance is involved in a reaction. You could be trying to figure out how much of a certain reactant you need to complete a reaction, or you could be trying to figure out what amount of product is produced in a certain reaction. Now you might be thinking, whoa, Jade, what the heck are reactants and products? And the answer is super simple. Reactants are the chemicals that go into the reaction, or the ones on the left side. The products are the chemicals that come out on the right side. Like so. Now that you know some background info, let's get to the real reason why everyone's here. How to stoich. And yes, once you learn how to do stoichiometry, you can call it stoich because that's what all the cool kids call it. So today, we'll only be getting into standard stoich problems where you find out how much product will be produced. But if you would like me to go into more advanced problems, please let me know in the comments below. Alright, so here's a simple example. Find the amount of water produced in grams in a reaction involving 20.0 grams of hydrogen and an excess of oxygen, using this equation here, which is 2H2 plus O2 is equal to 2H2O. Now, make sure to notice that we have three significant figures for our 20.0 grams of hydrogen. Alrighty, so now there are a few steps that I like to follow when solving stoich problems. Some people may skip steps or have different steps, and you can certainly choose what you want to follow based on what works best for you, but in my experience, this is the easiest way to solve a stoich problem, especially if you like being able to see all of your calculations clearly. We'll call these steps Stoich Steps because I like alliteration. Now, let's apply these steps to our example problem. Okay, so step 1, write out all of the molar masses of all of our products and reactants. You can do this by looking at your periodic table, which should have the molar mass of each element that your chemicals are composed of located at the bottom of each square. If I were to include an entire periodic table in these slides, you wouldn't be able to see anything, so I've only included the tiles of each element that is involved in our reaction instead. Now, let's try this out with our example. Take a look at the hydrogen square. Do you see its molar mass? Yep, it's 1.01 grams. But since the chemical whose molar mass we want to calculate is H2, we must add another 1.0 grams to the total molar mass, or multiply it by 2, which will get us to 2.02 grams per mole. Now we can do the same thing with O2, whose molar mass would end up being 32 grams, because 16 grams times 2 is 32. And finally, H2O would have a molar mass of 18.02 because we'd multiply 1.01 grams times 2 and then add 16 to it, which would get us to 18.02 grams per mole. Now we're on to step 2, which is to figure out what the limiting reactant is. In this case, we already know that it's H2 because we have an unlimited or excess amount of O2. But in a more difficult stoich problem, you'd probably get two different amounts of reactants, so you need to find how many moles you have of each. Don't worry, I'll go over one of those after we finish this problem. Anyways, in case you guys have forgotten how to calculate moles, let's go over exactly how we can do that. First of all, we know that we have 20 grams of hydrogen, which we've put right there. Now we've also calculated that hydrogen has a molar mass of 2.02 grams, which means for every 1 mole of hydrogen, we have 2.02 grams. We can write this out as a fraction. Which one do we want on top? Well, you'd have to think, which one am I solving for, moles or grams? The answer is moles. So we'd have to put moles on top as 1 mole over 2.02 grams. Now we can go ahead and multiply our 20 grams by our fraction to get us approximately 9.9009 moles of hydrogen. But we don't want moles of hydrogen, we want moles of water, right? H2O. So how would we convert these moles of hydrogen into water? Well, we need to find the mole ratio between hydrogen and water. In order to do this, let's take a look at the reaction. As you can see here, you need 2 H2 molecules in order to make 2 H2O molecules. As usual with these ratios, you want the unit that you're trying to solve for on top, meaning our ratio would be 2 H2O molecules over 2 H2 molecules, which would basically give you a 1-to-1 ratio. This means that we can solve this here and find out that we have 9.9009 moles of H2O. But remember, we need this to be in grams, which will bring us to our final step. Alrighty, so our third step is fairly simple. All we have to do is convert our 9.9009 moles of H2O into grams. Now, in order to do that, we'll need to use another ratio, 18.02 grams over 1 mole, since we want to solve for grams. So now we can go ahead and multiply this ratio with our 9.9009 moles to get 178.4158 grams of H2O. Or with sig figs, since remember we have 3 of them, we'll go 178 grams of H2O. Got the hang of it? Great! Now let's try a more complicated example. Okay, so the problem wants us to find the amount of nitrogen dioxide, NO2, in grams produced from 62 grams of nitrous oxide, which is N2O, and 62 grams of oxygen, or O2. Now, I highly recommend for you to pause this video and try solving this problem on your own first, but if you're not totally comfortable yet, go ahead and follow along. Okay, at this point, I assume you guys have already finished this problem and are looking to check your work or would like to be walked through the process of how to solve this. So let's get started. Okay, so as always, my first step is to write out the molar masses. In this case, I'll make it quick and solve it for you because that's pretty easy. So N2O has a molar mass of 44.02 grams per mole. Oxygen has, as we already know, a molar mass of 32 grams per mole, and NO2 has a molar mass of 46.01 grams per mole. Now our next step is to figure out which reactant is the limiting reactant, because we don't have an excess of either in this case. So in order to do that, let's calculate how much nitrogen dioxide can be made with each reactant. We can start by calculating using N2O. In order to do this, let's convert our grams of N2O into moles. So 62 grams of N2O can be multiplied by 1 mole over 44.02 grams N2O, which is its molar mass, which will get us 1.4084507 moles of N2O. I shortened it to 1.408 here because we don't have much space. Now we need to convert this into NO2 with a mole ratio of 4 NO2 over 2 N2O. And that'll get us 2.816904 moles of NO2, but I shortened it again. Now we can do the second reactants calculation. So let's go ahead and multiply our 62 grams of O2 by 1 mole over 32 grams. This will get us to 1.9375 moles of O2. Now let's do the same thing we did with the mole ratios earlier, only now we multiply these moles of O2 by 4 moles of NO2 over 3 moles of O2, which will get us 2.583333 and so on moles of NO2. Now, in order to determine what the limiting reactant is, we need to figure out which reactant produces less of the product. Now in this case, it should be oxygen, right? Because oxygen produces less NO2 than N2O, as 2.583 is smaller than 2.816. Okay, so now we can go ahead and convert the 2.583333 moles of NO2 into grams by multiplying this number by its molar mass, or 46.01 grams, which will get us 118.859 grams, or with sig figs, since we only have 2 this time, 120 grams of NO2. Alright, so how did you guys do on that problem? Did you get it right? Let me know in the comments below if this video was helpful, or with what topic you would like me to cover next. And of course, don't forget to spread the love by smashing that like button and subscribing to our channel. Then until next time, I'll see you guys. Bye!